Hey folks, welcome back to the channel. This is going to be part 7 of the Tesla powered Volkswagen convertible Super Beetle conversion, and continuing with the contactor box, the control box, just roughing it out. We'll do a number of other things in the video, but in the last video I showed the raw box that I got, so I started populating it with all the components. And here I have the main battery, the high voltage 150 volt DC from the Tesla batteries. The cutoff switch right here, that's going to go into the positive side on the motor. And I was able to bend some bus bars, if you can see it down in there. So I took some copper 1/8 inch by 1 inch that I sourced on Amazon and put it in my bender, and I made some real nice connectors here to the DC motor relay, or as they call it, a contactor. So when this is energized from the motor controller, this will close the contact and put 150 volts DC onto the motor. Then I made a little jumper off the main contact switch into the bus bar. Then I can have a nice tap connection coming from the side through the gland nuts onto the bus bar. And then I have my negative shunt for the meter. It's going to monitor all my current being used, how much battery I have left, etc. So this will be the negative coming in from the battery pack, 2 leads on the side for the shunt, and then a bar, again I did on my bender, out of the 1/8 inch copper into the negative bus bar. And these are all my relays. These are USM 11s, which are really nice. They mount on a DIN rail, come off and on, very easy. And as example, one's going to be my heater, one's my high voltage relay, which is right here, and so on for my other devices. But what's nice about these, pop up the lever, and that takes these little fuses. Pop it in, close it up, and you're ready to go, and then this will glow if there's current. I also mounted my main 12 volt DC battery disconnect in here also. So this whole box is going to go underneath the back seat right on the driver's side, so I can open up the door on the driver's side, reach in and just cut off all the power from the battery packs. Then I had all this space up in the lid, so I decided to make all my terminal connections here, and then this will just have a few cables here that I'll zip tie on and fold back onto the main box, so that should make it nice. Also, I had to take a piece of ABS plastic and create a standoff area so I can run the screws down for the terminals. And then also I used the existing standoffs in the electrical box here to cut a piece of ABS into the base and screw that down. That way I have clearance for running all my mounts for the bus bars, the shunt, the contactors, etc. Then the other box that I have made up, I found this on Amazon, nice little clip box. But this is going to be my 230 volt coming in from my wall charger here. That's going to come right in here through the J1772 receptacle into the what was previously the gas filler cap on the side of the Super Beetle. Open it up, plug it in, and then 2 line voltages are coming in here to give me my 230 volt. I know this is getting technical here, geeking out a bit, but 230 volts comes in here. In addition to the CAN bus control from the BMS to shut off the chargers, shut off the motor and all that good stuff, there's going to be a CAN bus communications between everything. This is going to be an analog way, so if I get up to 150 volts and it still the CAN bus maybe have an error in communications, I could also have an analog shut off that will kill the battery charger and create a little safety in here. Also, this is going to be the AVC2, and this is going to control my pilot connection and proximity on that plug on a public charger, so that'll take care of that. Also in here is my voltage prescaler that's going to go into my gauge on the dashboard. The idea of this is divide by 5, so I can take my 150 volts divided by 5, and then this will put out 25 volts so I can run it at the dash. So that way I'm not running high voltage to a gauge up in behind the dashboard. But other than that, let's get on to the next project. One of the next things I need to do is, this is the motor mount to go to the Volkswagen transmission. And this is the bolt holes for the B face coupling on the motor. Here's the flywheel. But this is the Hyper 9, high voltage Hyper 9 motor, electric motor, 3-phase motor. And I had to put a spacer ring on here that was provided by EV West. And then here's the shaft with the keyway in it. So what I need to do is, this is the coupler that needs to go on, and then the flywheel will bolt to this. But this is a zero interference coupler, which means I have to heat this up to 600 degrees Fahrenheit and then expand it so it'll slip down over the keyway and the shaft, and then it'll contract and be a really good strong mount. So I need to heat this up with a torch, get it up to 600 degrees, slip it on, and hopefully that's going to go well. Alright, so I have my heat gun. Shoot that. Right now I'm starting off at 64 degrees. I need to get this thing to 600 degrees. So let's give this a shot. Try to slip this on. So now that the coupler is on and cooled off a bit, putting the motor mount onto the motor. Again, this is a B-face motor. And on the side over here, I have my 3-phase wiring connections. And this is the top where it has the bolt holes tapped where the motor controller is going to mount. So I have to make sure it's clocked in line with that. But I got everything lined up. I got blue Loctite on the bolts. And get these installed. Next step is to put the flywheel on. And what's nice is this is a lightened flywheel rather than the original Volkswagen flywheel, which is huge and much heavier. I don't need the inertia, I don't need the mass of the flywheel with electric motor now. And the problem with the original Volkswagen flywheel is the vibration. It's not a very well made, balanced flywheel. So this is a lightened aluminum, totally balanced. So this will have the vibration that the original steel Volkswagen flywheel would have. And there's a needle bearing inside here for the pilot bearing for the transmission nose to go into, which is real nice. Nice needle bearings in there. I'll make sure to butter that up with some grease, but we'll get some blue Loctite onto the bolts and get these mounted, and then I'm ready for the clutch. Motor's all prepared, ready to go, and got the clutch alignment tool inserted into it for when I get the clutch in. But there it is spinning. Next thing is to mount the motor controller up on top here, and then I need to make up some high voltage cables from motor controller onto the 3 terminals for the 3-phase AC. Alright, so this is the motor controller. Then I have my positive coming in from the contactor, switch in the control box, connected to the battery, positive, and then the negative coming in. This is DC, direct current. And then it's going to convert, this is basically an inverter and a motor controller all in one unit, and it's going to convert to 3-phase AC out. So it's basically where Edison meets Tesla here. But and then here is my big pin connector for all the wires, control wires. So not only is this an inverter for producing the 3-phase AC, it also provides the contact point input for regenerative braking, for the CAN bus for monitoring battery voltages, temperatures, and so on. So it's a pretty sophisticated unit. But since it is an inverter, it's going to produce a lot of heat. So I have to water cool it with basically a D5 little radiator with a couple fans and a pump and a reservoir. But the bottom of this plate has to be mounted onto the chiller plate. And then this chiller plate, all this has 3 bolts that you're going to mount onto the motor mount on the motor and kind of cantilever out and hold everything together. So on the side is an 1/8 inch MPT fitting, which I had to order a couple fittings from Amazon. Home Depot, Lowe's didn't have it. But 1/8 inch to a 3/8 inch bar connection, then I can run my coolant hoses to the radiator and to the pump and so on. But I have to prepare this now, so I'm going to use 1/4-20 stainless steel bolts on each 4 corners to clamp this down to the chiller plate. And then I have this Loctite. This is SI 598 CK whatever Loctite, and this is going to seal the plate down to the chiller plate and also give me some thermal transfer. So I need to lay a bead all the way around and then through the center sections here, and then have this all sealed up and clamped on. So the water's going to come into here, go around, and then exit back out again. And that'll keep the motor controller nice and cool. I have the motor controller mounted on the plate, kind of cantilevered off of the Volkswagen motor adapter. And the next step is to take my 3-phase AC and tie it onto these points. So I need to make up cables that are going to come up here like that, and get everything connected. And that'll finish this up. I'll have the harness coming in, and then this is my position sensor, kind of like a cam position sensor in a regular gas or diesel car. That's what that is, and then a temperature sensor that'll go into the motor controller. I'm making up the high voltage cables for the 3-phase from the motor controller to the motor right over there. And I'm using 2/0 cable, which I have about 50 feet in a box there on the floor. But I have to put the lugs on each one of these, crimp them with a hydraulic crimper, and then shrink tube on. So let's get after this last one for the 3rd phase of the electric motor. First thing I want to do is take one of the lugs and mark back how much I need to cut off the insulation. So I like cramming it up into the head of the lug a little bit. So that's about right there. And then get the razor blade cutter here and just cut around the insulation. This is double insulated wire, heavy duty stuff for really high voltage, DC rated. So just go around it. And don't cut into the copper. And you'll hear it change when you're getting close to the copper. That's the sound of it. Alright, so now I've got copper exposed there when I bend it. I'm going to take my knife, cut back a couple times. And then peel off the insulation. You're left with the braided copper wire. And now what I like doing is pinching it a little bit, and then as I go on, I want to get all the braids done into that lug. So I spin it a little bit and then slip it on. And then the other thing I like doing is pounding it down into the head of the lug. So I push the wires down into the head of the lug, and I need to straighten it up a bit. And then I've got a hydraulic crimper. This is a 10-ton crimper that goes up to 2-0 wire. So this is 2-0, which is 2/0. If you're looking to source it on eBay for any of your lug connections or the wire itself. But inside this hydraulic crimper, you have little dies that just pop in with a magnet, like so, one on either side. And it's nice they're magnetized. And then what I'm going to do is turn it upside down. It has a valve. Close the valve. And then I'm going to put it through here. Might be hard to see. And then line it up. And it takes a little bit of practice, so you might want to take some scrap wire and try it out. But I'll put the Amazon link in the description for the lugs and also this hydraulic crimper, which works really well. So the valve's closed, and this is a 10-ton crimper. And then get it so the back is just about 1/8 of an inch from the back of the die. Tighten it up. Keep pumping. Alright, I think that'll do it. So I'm going to turn the valve, open it up, the dies will retract, and you're left with a really nice crimp. And then always give it a tug test. Make sure it's on there. The next step is to cut some of this shrink tubing, and this is heavy duty high voltage shrink tubing. It also has glue inside, so when it heats up, it will actually glue itself onto the lug and also to the cable, the wire. So I like cutting for this about a 2-inch piece. Might as well cut the other one too while I'm at it on the other side. And this is a PVC cutter, but I like using it for a lot of different purposes. I'll put the Amazon link in the description also for this. Works really well for cutting this stuff. There it goes. So next I'm gonna slip this on the end of the lug. And then I want it just right up to the edge. I don't want it going onto the flat surface because that would block the connection when I bolt this down onto the terminal. And I'm still left with quite a bit covering the jacket itself on the cable. And then get yourself a good heat. Don't use a flame like a torch or anything because that kind of bubbles this stuff, but just a good heat gun. And then we'll get it all shrinked on here. And just work it down to one side, you'll start seeing it shrink. And then when it does a pretty good job, then turn it a little bit. And once you get this done, you'll be an expert at crimping cables. And you could use it for your solar projects, use it for your car builds, anything. And then you want it hot enough where you start seeing a little bit of the glue coming out the end. Probably can't see that because you see a little bit of wetness right there. And don't touch this once it's done because it is very hot. There you have it, one end done and about probably about 22 to go, but it turned out real nice. You can see the glue kind of oozing out around the edge, but that one's done. Now I'll get the other side done, and then I'll have the wires, all 3 phases of the electric motor connected to the motor controller. So this kit comes with a variety of different dies that you put in, all the way up to the large stuff to the smaller stuff. So if you have any lug, any crimp connections, even cable connections where you're doing like stainless steel cable crimps where you're joining it together for like railings and houses and stuff. This works great, and this is about 50 bucks on Amazon. I'll put the link in the description. Cables are done from the motor controller down to the motor. Again, 3-phase. Next is to put the harness in and connect up the temperature sensor and then also the rotor position sensor. The next thing I need to do, this is the harness for the motor controller, and this will have all your wires, CAN bus and everything in here. But this connector here, this is shielded, foiled, twisted pair. I need to put the plug-ins onto this, once for the rotor position sensor and then once for the thermistor. All right, the Super Beetle's back in the workshop here, and a lot to do so the assembly can start after all the components that I made. But the first project I'm going to tackle with it back in the shop is putting the charge port receptacle into where the gas filler used to be on the front of the Volkswagen. So it's going to go in something like that. But I need to recess it in so it's flush, and so I can shut the door. So I've got about probably 1.5 inches that I need to sink it in. So what's nice is I have a charge port on the wall here with the cable, and just come up, turn it on. And this is a EV charger. It's a 40 amp, 230 volt or so, but I could take the J1772 charger right here, take the cover off, and then I'll just be able to plug it right in and charge the car up. So that's the goal here. It's going to take a little bit of tweaking and modification to get it in, and the challenge is on the Volkswagen Super Beetle, there's the hood hinge comes down right and pretty much rubs this side, the left side of the filler housing where the original gas cap went. So I'm going to have to do some figuring out, maybe do some CAD design, cardboard aided design, and see if I can sink this in and still be able to plug the charger in. So here's my attempt to put the J1772 charge port into the original gas filler door. And I haven't seen this done on YouTube anywhere, so this might be a YouTube first. But the challenge is that when the hood's down, the hinge, block the light, the hinge comes down, starts interfering with the plug connector. So to the edge, I have about 3.5 inches to this lip to play with to sink this in. And this connector's about 2.25 inches deep. So I got about 1.25 inches that I play with. And I took the box off the back of this connector. It goes like so. And there's just not going to be enough room. This sticks out way too far. So I'm going to have to devise some kind of shield bracket to bring the wires out and then do a right angle. This is the original stamped steel that went in there, and it had tack welds. So I drilled out the tack welds. And I like using this tack weld drill bit, which just takes out the outside. A locating stem on it that goes in the center of the weld and just kind of eats around the outside edge. So I'll have a link on Amazon for these. They work great if you're removing tack welds. But so I'm going to get this onto a piece of blank sheet metal, trace it out, and then devise some type of box to go into the back to house the receptacle. So hopefully this attempt's going to work. So I made the blank out of a piece of steel, and now I'm ready to start cutting the holes and then building a box in behind here for this to mount into. So I fabricated up the back box that's going to house the receptacle, and now I just need to weld around the edges and then tack weld a couple more spots and then get it test fitted, and hopefully it's going to work. All right, so I was able to get the new module installed for the charge port, but let's go ahead and check it out here. I'm going to do a little bit of body work around the flange that I made. All right, I got the charge port installed, the door back on. Need to do a little bit of body work to mold in the door properly. These things never really fit to begin with, but I'll do some fiberglass work and get that cleaned up. But there's the new charge port connection. The charge port is complete. So boy, that was a chore, and I've never seen it done on the internet or on YouTube anywhere, but yes, it can be done. So go up to it, flip the door open. There's the connector. Turn my charger on. Grab the connector here. And check this out. Lock and loaded. Very cool. Anyway, let's go ahead and wrap it up. And thanks for watching.